So, what could possibly connect a classic sci fi film, a puzzle from the Victorian era, and a piece of abstract art? I know it sounds like the beginning of a very strange joke, but today we're going to pull back the curtain on a hidden mathematical reality that actually unites them all. This is the mystery of brick space. And this quote from the great mathematician Sir Michael Adia just nails it. Mathematics may be art, but to the general public, it is a black art, more akin to magic and mystery. We are about to dive right into that magic, but don't worry, I promise we're going to make it all make sense. Okay, so our first clue comes from the movies. You've got Stanley Kubrick's masterpiece, 2001: A Space Odyssey. And this bizarre black monolith just shows up. It's this object of perfect, almost unsettling geometry that always signals some huge leap in evolution. And what's really wild is that while Kubrick was filming this, minimalist artists like John McCracken were creating nearly identical sculptures, totally independently of the film. Our second clue? Well, for that we have to go way back to 1850. It's a classic brain teaser called Kirkman's Schoolgirl Problem. And the puzzle sounds simple enough. How do you get 15 schoolgirls to walk in 5 rows of 3 for 7 days straight, but, and here's the catch, no 2 girls can ever walk in the same row more than one time. It's a pure puzzle of order and structure. And for our last clue, we jump over to the world of abstract art. This comes from a monograph in 1976 called Diamond Theory. An artist was just messing around with patterns and stumbled onto this 4x4 grid of triangles, and he realized it had these incredibly strange and deep symmetries baked right into it. So here's the big question, right? A sci-fi movie, a schoolgirl puzzle, and a painting. What in the world could they possibly have in common? The answer isn't some grand conspiracy theory. It's an architecture, a hidden mathematical world. All right, let's start pulling on that thread. And to unravel this whole thing, we're going to start with our most solid piece of evidence, that weirdly perfect 4x4 square from the painting. So the artist Stephen Cullinane found something amazing about this diamond design back in '75. He realized that no matter how he messed with it, if he shuffled the different kinds of triangles, or swapped the rows and columns, or even flipped the quadrants, the pattern that came out was always perfectly symmetric in some way. It was like a Rubik's Cube that was already solved, no matter how you turned it. This deep, unshakable order was just there. Now, here's where it gets really mind-bending. At the exact same time, a mathematician named R.T. Curtis was exploring a structure that was almost identical, but he was coming at it from the world of pure algebra. He was hunting for a rare kind of symmetry, and he found this system of what he called bricks that fit together with this very specific, beautiful logic. And he had absolutely no idea an artist was discovering the exact same logic with his eyes. And this just lays it out perfectly. On one side, you have the artist's diamond theory, a visual pattern he found just by playing around. On the other, the mathematician's miracle octet generator, an algebraic tool he built to study abstract ideas. You've got 2 people in totally different worlds who had no idea the other existed, and they both discovered 2 sides of the very same coin. So what is this structure they both found? Well, it has a name, and it's the key that unlocks this entire mystery. It's time for the big reveal. Welcome to Brick Space. Brick space is the name for this hidden mathematical universe. Now, don't get hung up on the technical name on the screen. Just imagine a universe that has its own unique laws of physics. It's not a place you can go to, but a world made of pure information, built from a set number of points and lines, all following simple on or off rules. It's like a cosmic game of chess with its own perfect, unchangeable logic. And here's the part that just might blow your mind. This entire, incredibly complicated world, with all its deep symmetries and connections, it's built from a surprisingly small number of pieces, just 63 fundamental points. That's it. So, how are those 63 points arranged? Well, they're not just a random jumble of dots. They're actually split into 2 very specific groups that are related to each other. Think of it kind of like a solar system. You have a central core of 35 points that form a special geometric shape, and then you have another 28 points sort of orbiting around it. It's the precise relationship between these 2 sets that gives brick space all its power. Okay, so we've got this abstract space. But what gives it these properties that connect it back to art and to puzzles? What are the rules of the game here? Well, it's all about the logic of symmetry. The rules are all defined by its symmetry group. Okay, think of it like this. You know how you can spin a snowflake, and it still looks like a perfect snowflake? That spin is a symmetry. Well, brick space has its own set of spins, a huge collection of ways you can shuffle its 63 points all around. But its fundamental structure, its deep shape, always stays perfectly the same. It's like its unbreakable DNA. And this quote from the psychologist James J. Gibson just gets right to the heart of it all. What modern painters are trying to do, if they only knew it, is paint invariants. So what's an invariant? It's simply a property that doesn't change when you transform something. It's the deep pattern hiding underneath the surface. And here it is. This is the payoff. Those amazing symmetries the artist found in his diamond matrix, they weren't an accident. They are a perfect visual map of the deep, unchanging rules of brick space. Through just pure artistic intuition, he had literally painted the mathematical DNA of this hidden world without ever even knowing its name. So, now that we found this hidden cathedral of ideas, let's see how this one abstract concept solves our initial mystery and reveals its true power. See, this hidden structure is unbelievably useful. It gives us the perfect blueprint for solving that tricky schoolgirl problem. Its logic is the secret engine behind computer algorithms that solve incredibly complex puzzles. Everything from scheduling airline flights to designing microchips. It's even used to create the error-correcting codes that make sure the data on your phone gets there without being corrupted. It's like a single key that unlocks doors in art, logic, and technology. So let's go back to those schoolgirls. How does it actually solve the puzzle? Well, the trick is to stop thinking of them as girls and start thinking of them as points in a geometric space. The walking groups become lines connecting those points. And it just so happens that this smaller space fits perfectly inside the much larger architecture of brick space, kind of like a small gear in a giant perfect machine. The solution was always right there, just waiting to be found in the geometry. And that same kind of elegant logic is why it's so powerful in computer science. See, the problem of arranging the schoolgirls perfectly is, structurally, the same kind of problem as something called exact cover, which is basically finding the one perfect way to fit a ton of puzzle pieces together. These are notoriously hard for computers to solve, but genius algorithms like Donald Knuth's dancing links actually use this hidden geometric structure to find the answer efficiently. And so we come full circle. On one side, you have the artist's beautiful design, born from a search for visual harmony. On the other, a mathematician's abstract graph, a network representing pure logical connections. They look completely different, but they're just two languages describing the exact same magnificent underlying structure. The mystery is solved. Which really leaves us with one last big question. If the same deep, invisible structures are bubbling up in our art, our puzzles, and our technology, what other hidden cathedrals of mathematics are out there, shaping our world right now, just waiting for us to notice the connections?